So in this problem, we are asked to find the derivative of the function f of x at this value of a. In other words, we're asked to find f prime of a. And I'm going to use this limit definition. There's two of them that we could use. This one I think is a little bit better. F prime of a is the limit as x approaches a, f of x minus f of a over x minus a. Remember, this essentially represents the slope of that secant line, or the average rate of change of the function over the interval from a to x. And then we're taking the limit as x approaches a, and this will give us the slope of the tangent line, which is the same thing then as the derivative at a. Once we find f prime of a, they ask us to then find the equation of the line tangent to the graph at a comma f of a. By the way, what is f of a? If a is 1/16th, f of a would be f of 1/16th. When I replace x here with 1/16th, I get 1 over the square root of 1/16th. The square root of 1/16th is 1/4. 1 divided by 1/4 is 4. So let's plug everything in, and just keep in mind the value of a is 1/16th. And so everywhere I see an a in this, I'm going to replace it with 1/16th. So f prime of a, which is 1/16th, is the limit as x approaches a, 1/16th. And then up here we have f of x, which is the function 1 over the square root of x, minus f of a, which is f of 1/16th, which we found to be 4, all over x minus a, x minus 1/16th. Well, we've got sort of a, when I look at this right now and plug in, if you plug in 1/16th right now, of course, you're going to get 0 over 0 indeterminate form. So we have to do some work to find the limit. And so what I'm going to do is, notice we have a pound fraction. We've got these smaller fractions, one up here and one down here, that are inside the bigger fraction. So I'm going to use the technique I've done in class, and that is to multiply by the least common denominator of all my smaller fractions. And so this denominator is the square root of x. This denominator is 16. I'm just going to multiply by the product in this case, right, which is the least common denominator in this case, 16 root x. Of course, I do that same on the top and bottom. The grand total I'm multiplying by is 1. Up top here, I am going to distribute this through. Okay. And when I do that up top, 16 square root of x times 1 over square root of x, the square root of x cancel, and I'm left with 16. And then just multiplying 16 square root of x times 4, well, that's just 4 times 16, 64 times square root of x. Now, down below, I'm not going to distribute the whole thing through. I'm just going to distribute the 16 through. So when I distribute the 16 through, I'll get 16x, what? Minus 1, right? 16 times 1, 6 is 1. And then I'll still have the square root of x outside. You could distribute that square root of x in, but I want to leave this factored down here. Okay? I have to do some work still, because when I plug in 1/16th, if you do it right now, you can check and see I still have the form 0 over 0. This is still indeterminate. Well, what can we do now? Well, you might say something about rationalizing either a numerator or a denominator. And, which one would I want to do? Well, in this case, I'm going to want to rationalize the numerator. Denominator is already factored. I sort of see this factor right here is the problem in a sense. When I plug in x equals 1/16th into this expression here, notice I'll get 1 minus 1 or 0. So I'm looking for this factor to appear up top. So I want to rationalize the numerator. Now, when you look at this, you might say, well, I'm going to multiply by the conjugate, would be correct. Would you multiply by 16 plus 64 square root of x? You could do that. But I'm going to make things a little bit easier, because I noticed before I do that, there's a common factor of 16 here. In fact, I distributed through the 16. I probably shouldn't have, is what I'm thinking. I want to factor that 16 out first. So when I factor it out, I'll leave 1 here, and then 16 factored from 64 is 4. So sort of back to this thing. And now what I'm going to multiply by is the conjugate of this in the parentheses, which is 1 plus 4 square root of x. And of course, do that in the bottom. It just makes the numbers a little bit easier to deal with. If you do the whole thing, it's just a little bit more involved and messy. Okay, so when I do that, what happens up top? So I have 16 here, and then I FOIL out essentially, first, outer, inner, last. 1 times 1 is 1. The outer is 4 square root of x. The inner is negative 4 square root of x times 1. And so the outer and inner go to 0. Last will be negative 4 square root of x times positive 4 square root of x. So negative 4 times positive 4 is 16. And what's the square root of x times the square root of x? That's just x. So I'm going to get negative 16x. Okay. Now down below, I'm just going to write square root of x, 16x minus 1 times this stuff in parentheses. I don't want to, full this out, expand this out. This is factored. Okay. Well, where are we at now? Again, if I plug in 1/16, I'm still at the same form. I'm still at 0 over 0. Okay. So what am I going to do? Well, if I look up top, I see two that look similar. Are these the exact factor? No, but what do they differ by? Just a negative, right? In fact, if I wanted to, I can factor a negative 1 out of here, which leaves me negative 16x plus 1, which is the same thing as 1 minus 16x. So in fact, notice there's that factor 1 minus 16x in the numerator. And what's going to happen is when I cancel these two out, I'll be left with a negative 1 down here. So if I cancel out these two, then what do I have up top? 16. Down the bottom, I'm going to bring this negative 1 out in front. So I have negative square root of x. And then don't forget this thing. Okay, so basically the 1 minus 16x is gone, that factor in the numerator and denominator. And that was what was giving us a problem, because now this function here is continuous at 1/16. If I plug in 1/16 here, the square root of 1/16 is 1/4. And then 1 plus here, again, 1/16, the square root is 1/4 times 4. 4 times 1/4 is 1. So here's what I get. This is the actual value after I plug in. 1 plus 1 is 2. 2 times 1/4 is 2/4 or 1/2. So I get a negative 1/2 down below. And 16 divided by negative 1/2 is negative 32. Whew. So that's a lot going on there. But there is the limit. And so this is our f prime of a, or our f prime of 1/16 in this case. I think in MyLab they have a f prime of a equals, and of course there's the result. Now, what about the equation of that tangent line? Well, the tangent line, what is f prime of a, or f prime 1/16? That's the slope, which is negative 32. The point we're talking about is really x1, y1 is a comma f of a, where a in this case again is 1/16. And if you remember, we evaluated f of a, f of 1/16 up here and got 4. So the point of tangency is this point. And so remember how we do this: y minus the y coordinate, y minus 4, equals m, the slope, times x minus the x coordinate. So this is the point slope form of the equation of a line. And now I can solve for y. I'll distribute the negative 32 in this case, getting negative 32x plus 2. Negative times negative is positive. And then I'm going to add 4, and there is my tangent line. Okay, so a little bit challenge in evaluating this limit, this derivative. But there is the result, and hopefully this helps. Again, your numbers may be slightly different than the original problem, but should be something very similar.